Okay, so we will continue with our chapter 3. Of course, we are in chapter 3, but we will start a new part, part 5. Okay. Change of basis. Okay. And here we are going to have two sections as well, or two sections, as some other parts, of course. Changing representations of vector or of vectors. Changing presentations of vectors. Okay. Before I can give you the definition, okay, let me show you the observation, or even yourself you can guess that if we are given a basis, a vector v, and a basis, for example, b, the representation of that vector v with respect to that basis b is not going to be the same if we are given a new vector, a new basis d. Okay. However, the vector is not changing. The vector v is still vector v, but representing that vector v in basis b is going to be different from representing that vector v in basis d, if you see. So the vector itself is not changing, but its representation is changing because the bases are changing. The bases are different. Okay, so this will lead me to the definition. Okay, the following definition. So the purpose of this section is if we are given a vector v, okay, and I know its representation, for example, in vector b. How can I know, or how can I get its representation in another basis d? Okay, what is the underlying map, or we can just say what metrics can I use to be able to get the representation of a vector from one basis to another basis? Okay, so let me give you the formal definition. Okay, the change of basis matrix for basis, okay, b and d from the vector spaces v, that means the domain space, is the representation of the identity map, because as I explained, the vector itself is not changing. So we are not doing anything to the matrix, to the vector. Therefore, it is being transferred to another basis by the identity matrix, okay? So the representation of the identity map, okay, defined as ID from V to V. We are not changing the domain space with respect to different bases, okay? With respect to those bases, So this is how we can write the underlying map. So the identity matrix from V to V. We are not changing the domain space. We are not changing the nature of the vector, or we are not changing the vector at all, but we are changing the basis. Okay, so we know how to represent, okay, a vector with respect to a basis. You have already seen it. So here the definition says that that representation is given by, so we can call it R PBD, representation from B to D of the identity map, which is, of course, as you already know, representation with respect to D of the element of the basis B. Okay, so I'm going to stop here with the definition. We can also write the following diagram. I like this diagram because it allows us to see clearly. So we can say that from V, we are going from V to V under the identity map, okay? And with respect from with respect to B and with respect to D. So here is the underlying map from V to V with respect to different bases, but the underlying map is the identity map, okay? So let me continue here with the following lemma. To convert from the representation of a vector V with respect to B to its representation with respect to D. Okay, use the change of basis matrix. Okay, so the representation of so if you want the representation of a vector V with respect to the new basis D, we can just multiply the representation. Okay, let me write it here. We can just multiply, left multiply representation of V with respect to the previous basis B by the representation of the identity map with respect to BD. So this is the change of basis matrix, if that's okay. So that is it. So conversely, okay, if left multiplication by a matrix changes basis. That means we have something like M matrix on the left hand side multiplied by the representation with respect to B of a certain vector is equal to the representation of that vector with respect to a new basis D. Then we can conclude that M is a change of basis matrix. Is that okay? We will see shortly in a tutorial how to change the representation of a vector with respect to a different basis. But I think from the definition and this lemma, everything should be clear. But if you still don't get it, don't worry, we will do some examples shortly. Okay, let me give you to continue. With this lemma. A matrix changes basis if and only if it is non-singular. A matrix changes basis if and only if and only if it is non-singular. That means it is one-to-one and onto and preserve structure as well, of course. Okay, let me continue with the number 4, corollary. Matrix is non-singular if and only if it represents the identity map with respect to some pair of bases. Okay, so this is also a very interesting concept to have or to look at. So basically the corollary is saying that a matrix is non-singular if and only if it represents the identity map with respect to some pair of bases. Okay, so you will be asking yourself, sometimes I am given matrices, okay, we are given matrices that do not look like identity matrix, but the subtle information given here is that we can let's assume the matrix to begin with is non-singular and it contains a bunch of numbers and it's not an identity matrix. But what this corollary is telling us directly is we can turn that matrix, we can change that matrix into identity matrix with respect to some pair of bases. And I am actually exaggerating a little bit. It's not perfectly identity matrix or yeah, it's not actually identity matrix, but I can call it diagonal matrix. I don't know if you can see where I'm going to, but basically, we will see it more into detail in chapter 5. Okay, so basically, the message I want to convey through this corollary is that we can transform the content of a matrix. We can change the content of a matrix with some appropriate pair of bases. So if you have a different pair of bases, then we can also transform the content of the matrices as well. I hope I haven't talked too much, but basically, I just want to lead us to, the future chapter 5, about how to diagonalize a matrix. Okay. I hope I haven't confused you. So if you don't get it, then ignore everything I have just said and just remember the corollary. Okay. So I think I'm going to stop here. And in the next video, we will do a tutorial. We will be given a vector and the two bases, and we will be asked to represent that vector with respect to the two different bases, and we will be asked to find that matrix that will help us to transform the vector from a certain basis B to another basis D. Okay, so thank you, and see you.